Now, going to the next topic, that is energies of particle in SHM.
Sir, can you show that formula now, sir? Okay, okay, sir. Thank you, sir.
So, energies of particle in SHM. So, when you take a particle which is oscillating, see, for the time being, I'm considering x-axis. It can be along y direction also. It can be vertical also. If you take a particle which is vibrating about its mean position, then you have extreme positions here. Here is an extreme and here is another extreme. Okay. So when you talk about the particle at the mean position, what does the particle have? Here, velocity is non-zero, whereas displacement is zero. At the extreme position, displacement is not equal to zero, velocity is zero. Okay. Listen to this carefully. What I'm trying to say is, initially, if you take the mean position to be the origin, yesterday we discussed, if you take that as the origin, the displacement of the particle is zero, whereas the velocity will be non-zero because it should have maximum velocity at the center, whose value is given as omega into a. At the extreme positions, what will happen? It will come to a momentary rest, as a result of which instantaneous velocity is zero, but the displacement is not equal to zero, it is maximum. So to put it in simple terms, here V is maximum, X is zero. Here V is zero, X is maximum. Okay. So this is how it works. When this is the case, what is the energy that is associated with the velocity of a particle?
Sir, could you repeat the question?
What is the energy associated when a particle has velocity?
Kinetic energy, sir.
Kinetic energy. So when I say energies, the particle has kinetic energy whose value is given as half mv square. Correct? And what is the velocity of particle in SHM? So what is the velocity of a particle in SHM? V is equal to omega A. Okay, omega A into, if I take the displacement of the particle in terms of x is equal to a cos omega t. If I take it like this, or I'll take it as a cos omega t plus phi naught. Okay, then omega A times sine of omega t plus phi naught with the minus sign. Right? So using 2 in 1, what do we get? We get kinetic energy is equal to half m into v square. V square is omega square a square sine square of omega t plus phi naught. Okay. So this will be half m omega square a square sine square omega t plus phi naught. Let this be equation number 3. Make a note till here. Done?
Yes, sir.
Okay. See, when the particle in SHM is also having a position associated with it, what is the energy possessed by an object by virtue of its position? Energy possessed by an object by virtue of its position is called as
Potential.
called potential energy. So here the object has potential energy, and the formula for potential energy in the case of SHM, don't write it as mgh because it will not have gravitational potential energy. It will have elastic potential energy because it is experiencing a restoring force. So U is given by the formula half kx square, since this is the formula for elastic potential energy. Okay. So U is equal to half into, what is the value of K that I told you in the previous case? It is M into omega square into, what is the value of X, guys? X is A cos omega t plus phi naught. The whole square. Is there any doubt in this term? I'll write the reason also, since K is equal to M omega square from previous topic. See, don't write in the exam as from previous topic. You should know this for your understanding. I wrote. And X is equal to A cos of omega t plus phi naught. Okay. So this will be equal to half M omega square A square. Can I write it as cos square omega t plus phi naught? Let me call this as equation number 4. So this is the potential energy of the particle at any instant, because the potential energy is a function of time. Similarly, this is a kinetic energy which is a function of time. Make a note of these 2 points. Done?
Yes, sir.
So what is the total energy of particle at any instant? What is the total energy of the particle at any instant? It is kinetic energy plus potential energy. Logically, that's the reason. That's the meaning, right? So what is the formula for kinetic energy? Half M omega square A square into sine square omega t plus phi naught plus, what is the formula for potential energy? It is half M omega square A square into cos square of omega t plus phi naught. Okay. So what is common in both?
Half M omega
Half
square
M
A
omega square A square into sine square omega t plus phi naught plus cos square omega t plus phi naught is how much? Sine square theta plus cos square theta. This whole thing put together is 1. So what is going to be the total energy? It is half M omega square A square, which is always a constant. Is it clear?
Yes, sir. Yes, sir.
Sir, always constant in the sense.
It's always constant. The sum is always a constant. M is constant, omega is constant, A is constant. Whereas kinetic energy is not constant every time because it is dependent on time. As time is changing, kinetic energy will change, potential energy will change. But what will happen is, though kinetic energy and potential energy with respect to time are changing, the sum of those two values will always be a constant.
Okay, sir.